Hello everyone, we have another example on magnetic circuits. First, let's get all the given information from the example. Here it says we have a main path length is 40 centimeter, so LC equals 40 centimeter. Now there is a small gap of 0.5 centimeter, so this is the length of the air gap here. And the structure of the otherwise whole core. Now the cross-sectional area of the core is 12 centimeter square, so here we have area 12 centimeter square. Now the relative permeability of the core is 4000, so we have mu r equals 4000, and the coil of the wire on the core has 400 turns, so we have n equals 400. Assume that Fringing effect in the air gap increases the effective cross-sectional area of the air gap by 5%. So we have a Fringing effect by increasement of 5%. So Fringing okay, given the information, find the total reluctance of the flux path iron plus air gap. So by saying flux path, so here he made it a specific iron plus air gap. That means this is iron here, this is iron, and plus the air gap. So that's what it means by the flux path. So we need the total reluctance. So what we need are equivalent, the total reluctance. Here it will equal R core or R iron plus R of the air gap. Why? Because they are connected in series in just one circuit, because there is only one flux throughout the whole circuit. There is no flux division, that means there is no parallel, so it must be series. That means it's connected like this. We have here the cores, the turns, the coils, so that means the source is here. Let's say this is R of core and this is R of the air gap. Now we want to get our equivalent, so we have to get RC first. RC is LC divided by mu times AC. Now LC is given 40 centimeter. 40 centimeter times 10 raised to power minus 2 divided by mu, which is equal, okay, we know that mu r equals mu divided by mu 0 here in this formula. Mu r equals mu divided by mu 0, so once we need mu, so we have to multiply these. Mu equals mu r times mu 0, and we already have mu r from the example 4000 times mu 0, which equals 4 pi times 10 raised to power minus 7, and the area of the core is given also 12 centimeter square. Or we can just multiply by 10 raised to power minus 4 to convert it to a meter. Now after doing the calculations, we can get the value is 66314.6. okay, this is ampere turns per Weber. This is the unit for the reluctance. Okay, now we want the reluctance of the air gap. R A equals LA divided by mu 0 times AA. Why do we use mu 0? Because in the air gap we use the mu 0, because mu 0 is already the permeability of free space, and air gap is a free space, so we use mu 0. LA is also given in the example L0. LA is 0.05. Now we want to get the reluctance of the air gap. We need to get LA and AA. So we have LA already, which equals 0.05 centimeter, and to convert it to meter, so we multiply by 10 raised to the power minus 2, so that equals, now AA is affected by the Fringing effect, so that means we multiply the cross-sectional area, which equals 12 centimeter square, times the increasement of the Fringing effect, which is 0.05. So that means 12 times 0.05 equals 0.6. Then EA equals the original cross-sectional area plus the Fringing effect, the increasement of the Fringing effect, which equals 0.6. The idea of the Fringing effect is there is some kind of increasement in the cross-sectional area. So there is the original cross-sectional area, and this is the 5% that represented by the increasement from the cross-sectional area, 12. So this is the value, the amount of the increasement, and we sum it with the original cross-sectional area to get the area of the air gap. So now we can get our A. And we use the mu0 because we already know want the reluctance of the air gap, and mu0 is the permeability of air gap or permeability of free space, which is the same thing. Times 10 raised to power minus 4 because we want to convert it to meter square. Now our A equals now we can get our equivalent. So it equals now we got the first requirement. Now we want to get the current required to produce a flux density, which is B of 0.5 Tesla in the air gap. So we need the current in the air gap. So as we already know, F, the magnetomotive force, equals Ni and equals also phi r. We have N and we need I, and we have R. So if we and phi equals BA, because we need the current produced by a specific value of a flux density, so we have to put the flux density in our equation. So phi equals BA. So we want the I in the air gap, IA. Now IA in the air gap, so we must use the area of the air gap. So once these two equations are equal, so let's put them in both sides. Ni equals BA R. So I of the air gap equals B area of the air gap, and the total reluctance divided by N, and the I of the air gap is just 0.5 times area of the air gap, which is 12.6 here centimeter square, times 10 raised to power minus 4 times the total reluctance 3820982 divided by 400. Now we got I equals 0.603 ampere. Okay guys, now we solved our example. That's all what we need to do. We got the total reluctance, and then we got the I required to produce a flux density of 0.5 Tesla. So that's all guys, I hope you understand it. If you have any questions, please leave them in the comments. So thank you very much, bye.